All right, good morning, everybody. Thank you for coming. And I am just really excited because today I finally get to interview Paul Beckwith. As you know, he's a climate scientist. He's probably the leading climate scientist on the social channels. He's been really great at informing everybody. And hold on, guys, I have a technical difficulty. We're getting a just a second. Damn it. You get to hear a repeat. Sorry.
It's okay. Happens.
Okay. Yeah, it's like Monday Madness, only it's not Monday. So let me finish introducing Mr. Beckwith. Um, so he's a professor at the University of Ottawa. He is, I guess, his focus is on abrupt climate change and oceanography at the moment, which is great. Understanding the oceans is very important with what we're going through right now. So we're going to receive some fantastic information, but let's just start out by introducing Mr. Beckwith. Say hi.
Hello, Christina.
Oh, sorry about all the problems this morning.
Yeah,
Um,
no problem.
we'll get through them all, but um, mostly what I want to talk about today is all the new developments, and there's been quite a few over the last couple of weeks. Um, on Tuesday, we had the new UN report on biodiversity, and I was wondering what you thought about that and how that factors into everything. I know your focus isn't in biodiversity, but uh, it is affected by climate change as well as anything else. And what you think and what you're seeing in your ocean studies.
Well, the new report is very comprehensive study. It's been in the works for a long time. It's actually about 1,500 pages long, I believe, and they haven't released the report yet. They've released a 40-page summary of some of the highlights of the report. So it'll be interesting to see when the the full report comes out. But I think a lot of us, a lot of your listeners are probably aware of what's been happening with biodiversity. I mean, the rate of species extinction is far greater than the natural sort of background rate, if you like. And when you think about all of the weather extremes that we've been experiencing recently, whether it be heat waves or torrential rains leading to flooding or the drought from heat waves. I mean, it's high temperatures. It's very, very difficult on species. I mean, we can always go inside a house and which has a somewhat moderated climate. If we have air conditioning during very hot areas, and we have shelter, right? But
Mm.
plants and animals in the environment are subjected to these incredible changes, and it's just the changes that are the worst, the abrupt swings from one state to another state. So I think what's happened, of course, is that we're getting Arctic temperature amplification. The Arctic is warming extremely fast, so that lowers the temperature gradient to the equator. So the jet streams are slower and wavier, and we get these very sharp ridges going high up, right up into the North Pole, and we get these troughs going down to the equator and actually crossing the equator and going below. So we're getting so the frequency, the severity, and the duration of extreme weather events has increased. We're getting extreme weather events where we never used to get them before. And we're also getting blocking of the jet streams. So we're getting persistent weather in some places. But I think one of the most noticeable things is the torrential rains that people are getting. Like I was just reading this a few minutes ago. I mean, Houston, of course they had Hurricane Harvey a few years
Right.
ago, right, which dumped 5 feet of rain in some places, and just now there's places in Houston that have had 4 inches of rain in half an hour, right? So there's local flash flooding and things, but we're affected, of course, by all these things, but the flora and the fauna, the plants and animals that are living outside in the environment, how do they deal with all of these things? So, in general, as our planet's warming, species are migrating to closer to the poles, or if they're
Right.
on
But
a
the
mountain.
plants can't do that. The plants are kind
Yeah,
of stuck.
Well, they can't do that quickly. They're not they're not triffids. I don't know if you remember the book The Day of the Triffids, where the plants were actually walking.
Oh.
Um, but it's a book I had to read years ago in high school. But I mean, seeds travel, right? So
Mhm.
plants do actually can migrate and move, but the soils have to be sufficient, and it takes a long period of time. But it's not really a surprise. And the oceans, we've lost 90% of the large fish in the ocean, and that's from overfishing.
Mhm.
And of course, we have ocean acidification problems. We have dead zones in the oceans. We have stratification. As the ocean warms up, the water gets warmer. Warm
Mhm.
water floats on top of the cold waters. There's less vertical mixing, and the nutrients are down below. They no longer come up to the surface, so we have less phytoplankton on the surface, and they're the base of the food chain. So yeah,
Right.
we've really done a number on our planet, and we're not really showing any signs of trying to reverse things.
Isn't that the saddest part? Like we are not trying to you don't see any action, any meaningful action from our politicians to actually do anything about it. In fact, we're increasing our energy use, we're increasing um, our industry,
Yeah,
we're increasing our shipping, we're increasing everything that's contributed to this problem instead of actually doing anything to mitigate it. Um, that's what's
yes,
devastating to me.
yeah. I mean, it appears our politicians are hell bent on destroying everybody
Yeah.
with their policies. I mean, they're not neutral. They're not. The problem is worsening continuously, and politicians are driving it to be worse. They're
Right.
actually physically doing policies and supporting increased fossil fuel exploration. They're driving us into the ground. That's literally what they're doing.
Yes, and how do you stop them? We'll get to that later. But for now, what is happening with the Arctic sea ice? I've heard you say on another interview that it was um, let's see, the melting started earlier, like a month and a half earlier. Is that the
Yeah,
case?
yeah. See, one of the, of course, yeah. I mean, the Arctic is in it. We're going to lose Arctic sea ice very, very soon. By the end of the summer melt season, and have a completely blue ocean in the Arctic. It's just
This summer?
by a summer within the next 4 or 5 years, I would say,
Right.
is an extremely high probability. This summer, who knows? It's very hard to know from one year to the next, but we're definitely trending to a much lower amount of ice left in the Arctic by September.
Yeah,
We're
and it's
well
just not.
below, yeah, we're well below
Sorry.
2012, which was the previous minimum
Right. Yeah, which is
record.
crazy. But density is just as important, if not more important than than extent. I mean, just
Yeah,
common sense tells you if you have a thin ice layer, like I see that in here where I live in
yeah,
the winter, if you have a big trough with a little thin layer of ice on it, that melts a lot faster than a small trough, which tend to get thicker ice because a smaller area to freeze. And obviously, the big trough is going to melt faster with the thinner ice. Just,
yeah.
you
Yeah,
know,
I
uh,
mean the ice is yeah. I mean the easiest thing to measure is of course the extent of the sea ice, which is defined as any area with at least 15% sea ice. It can be 85%. It can be 85% water, 15% ice, and it's counted as an extent. The area is the region with 100% concentration of ice. No gaps, no water gaps. But the volume is the key thing, the volume of the ice. And you mentioned, I mean, the density. The problem is we've lost almost all of the multi-year ice in
mhm,
the Arctic. So this is ice that survives from one year to the next.
yeah,
So the 2 years or longer ice basically. And see, the thing is, when ocean water freezes, of course, ocean's about 3.5% salt, or about 3.5%, or 35 parts per thousand is the unit that oceanographers tend to use, or 35 PSU people may have seen, practical salinity units.
Mm-hmm.
So when that water freezes, the water molecules freeze and they try to reject the salt. But overall in the frozen ice, there's pockets of salty water or brine. So if you take ice that is just frozen, and remove it from the ocean and melt it and measure the salt content, it's not going to be 3.5%. It might be about 1% or 1.5%.
Right. So it's pretty much watering down the salt content.
Yes, and
with
then
fresh water.
Yes, and then over time, those brine pockets will, by gravity, kind of leaches them. They kind of percolate through the ice and leave at the bottom into the water. So over time, the ice becomes purer and purer. And if the ice did survive to multi-year ice, then it would become almost pure ice, after a number of years. And, people living up there knew that. They would go to the old harder ice and melt that for their drinking water. But
right.
but the ice that has got all this salt and brine pockets, you can imagine it's sort of like, it's perforated. It's sort of like Swiss cheese. It's not very strong. It'll melt more quickly than multi-year ice. It's not as hard, break up more easily. So we've got an Arctic now that's mostly this weaker perforated ice, and it can melt out a lot faster.
Right. And no one knows exactly how long that's going to take. I mean, there's been some estimates as far out as 2050, and I am so skeptical of those estimates. I mean, why are they so optimistic, I guess?
Yes. Well, see, we still have a huge problem in that policymakers tend to overweigh, they tend to set their policies, and their views on climate are they're based way too much on the Intergovernmental Panel on Climate Change report. Now, the AR5, Assessment Report 5, came out 4 or 5 years ago. But of course, the data, any papers that were published to make it into that report, they had to be in the literature for 2 years. And the actual measurements may have been made, and it may have taken a year to do the measurements and publish the paper. So that's a 3-year lag. So if the report was out in 2014, 2015, then you have to go 3 years prior to that. And that's when the data was collected, and that's what the report is based on. And that's what policymakers are using for the most part. There are updates, and so what we need is, we don't need a bulky new report every 5 to 7 years, which is what we get now. We need updates every single year, which policymakers then use, because climate is changing so fast.
We probably need one every 3 months.
Yeah,
as fast as things are changing.
Yes, I mean, we have abrupt climate change going on, very, very rapid climate change, and we need to have response in the scientific community to match that, basically.
Right.
I'd love to be able to Google, when I Google climate change faster than expected and Google climate change slower than expected, and actually find equal hits for both categories, and we know that scientists have a more fair, balanced view of what's going on. And right now, you can't find anything, if you Google slower than expected.
Right.
Right. So the scientific community is way, way behind in assessing the problem. And, there's new reports that are coming out all of the time, which are showing how severe and dire climate change is. So there is more and more recognition, but the mainstream media has completely dropped the ball on letting people know.
It's
also,
like
scientific community has dropped the ball too.
Yeah.
Completely. I mean, the scientists are, our world is too specialized. We don't have enough people that are looking at the overall picture, trying to figure out the connections between things and what's really happening. We have a world of specialists who don't really want to talk too much outside of their expertise, their specific narrow field of study.
Right. Like there's the people that just focus on just the climate issue and don't consider biodiversity. And we can't live without our food supply, and our oceans are dying. And and like you said, all the animals are trying to migrate. No, none of them can adapt fast enough to these changing conditions. So what do you think this has to say about our food supply, and how early do you think it will affect it?
Well, for many years, I've been saying that we're in a climate emergency.
Mhm.
And, at least it's encouraging to see that there's lots of different groups around the world that are declaring climate emergencies. It started with the cities, and more recently, the MPs in the UK, and also just yesterday, Ireland. The countries are saying we have a climate emergency. I've been sort of pushing the Canadian government to get with the program and do that. And it's like butting your head up against a brick wall, basically. But
Right.
yeah, yeah. So I mean, this year we've been seeing, well, talking about food, I mean, so back in 2010, there were massive, there was a stuck configuration of the jet streams, such that a very strong trough was going over Pakistan, and then the ridge associated with that trough was going over Russia. And the trough over Pakistan caused tremendous. This was in, I believe, July to August in 2010, and the ridge, the trough over Pakistan caused rains almost every day, and three-quarters of the country had severe flooding. And the trough over Russia meant, under trough is high pressure, very hot, no rain. So they had temperatures 30 to 35 Celsius, which is very unheard of over Russia in that time period. And there was basically drought and crop failure. They lost 40% of their grain crop. They didn't export any grains that year. And that caused shortages, which triggered the Arab Spring and the food shortages. And, we know about Syria, record drought from 2006 to 2010, like a 1 in 1,000 or 1 in 2,000 year drought. So farmers couldn't farm. 1.5 million lost their jobs, moved to the cities, and there was a lot of civil unrest and unemployment, and the country splintered apart. So, these food shortages, there's nothing that gets people out in the streets protesting more than food shortages. So,
That
what
does
are
make
we having? Yeah. So what do we have now? Well, now we've had all this flooding in the U.S. Midwest, in the farming belts and stuff. So farmers, and because of Trump's tariffs and trade war with China, a lot of grains weren't shipped to China that normally would have been, and elsewhere in the world. So farmers couldn't make money selling it, so they stored this stuff. So there was a huge amounts of food that was stored in grain elevators and things in the U.S. And of course, we've had this massive flooding over this entire region. We've seen images of the grain elevators filling with water at the bottom, and that would expand the grains, and then it would explode the elevator. The elevator would kind of explode, like it would just break apart because of the pressure of the grains expanding on the inside of it. Also, the planting has been greatly delayed, and crops lost, winter crops lost, etc. So, basically, when we have now, other places in the world, it depends on how their food is going. But eventually, the turmoil from abrupt climate change will be severe enough that we get multiple failures in multiple places around the world of food, enough to trigger shortages and spikes in prices. Food prices doubling or tripling or quadrupling. So when will that happen? Don't have a crystal ball on that, but the risks of that happening are getting higher and higher, of course. And as we go and lose Arctic sea ice and go to the first blue ocean event, then the risks of, we're going to get more and more disruption of weather patterns around the planet, more and more extreme weather events, and that will greatly increase the risks of food shortages. So, if I had to guess off the top of my head, I would say we're probably heading for a blue ocean event within, say, 4 or 5 years at the very maximum, or at least that's what the trends are pointing to. And within about a decade of that first blue ocean event, I could see the blue ocean being there year round in the Arctic, and we're in a totally different climate, and that would be in the space of the blue ocean event plus 10 years at the max. So that would be about 15 years out at the max. So, we're talking about, I'd say the probabilities are getting very, very high of the food issues coming to a head within, say, 10 to 15 years at the maximum. Maybe sooner than that. That would be my best guess. Today, I could change that in a week, with new information.
Correct. Yeah. Another concern of mine is water. With all the flooding, a lot of the groundwater is going to get poisoned, and water is kind of a necessity for life as well. So I'm wondering what an effect all this flooding. We have flooding in Texas. We have flooding um, in the Midwest. We have flooding in Oregon. We have flooding in Idaho. Of course, there's all the flooding in Canada. How is that going to affect the clean water supply?
Yes, it's water, of course, is a huge issue. And when you talk about food, there's so much water that goes into food production, right? So it's really part of the same issue. Yeah, it's one of the things with these persistent weather patterns, like the jet streams getting stuck. If you happen to have a trough. Then you're getting torrential rains and very heavy rains, and our systems aren't set up to store all of this water, so a lot of it just runs over the land, runs into rivers, runs into the oceans, etc. I mean, we're not really storing it. Whereas other areas, like the U.S. Southwest has been under drought for many years. Texas.
That's where I'm at, but now we're getting tons of rain after
yes, that's
after
right.
many years of drought.
Yes, this is one of the things that is happening with abrupt climate change. We're getting, I call it weather whiplashing or weather wilding. For example, one year the Mississippi River can be at record flood levels, and there has to be triage done. Where do you release the water? You have to flood, you flood out a bunch of farmers' fields if you have that control, so that the water doesn't flood out a city downriver, right? And there's, basically the flow. The Mississippi is vital for economic transportation of goods in the U.S. Huge GDP, a huge percentage of U.S. GDP depends on transport in the Mississippi River, like massive amounts. So this one year you have the record flooding, and then the next year you have record drought. This happened a few years ago, and the water level was so low in the Mississippi that the U.S. Army Corps of Engineers had to go in and blast rocks on the bottom to keep the barge flow moving on the river. And then the third year, so after that, the third year was massive flooding, which exceeded the flooding from the 2 years previous. So this is booming, but from one extreme to the other extreme, back to the other extreme, and this is very, very hard on infrastructure. It's very, very hard on us. It's very, very hard on the plants and animals in those particular regions as well. So it has a huge effect on the biodiversity as well.
Right.
Also, also, in terms of biodiversity, a couple good examples are, Europe right now, because, and North America in the winter. We had a trough of the jet stream pretty much stuck over North America. And we had basically a cold blob, if you like, just sitting over North America. We had tremendous amounts of snowfall, and this is one of the big reasons why we're getting so much flooding now. Up in Canada, the snowpack is double what was normal in the huge watershed that feeds the Ottawa River, and which runs into the St. Lawrence, and the dams just don't have the capacity in the reservoirs to hold this amount of water. So as bad as the flooding was in Ottawa, then it made world news. It peaked last week, Well, the river dropped a bit, but now the river is rising, and it depends on the skill of the dam operators in the far north as to, you know, whether we'll set a new peak, because the water is rapidly rising, and now they're concerned that the you know, the water may actually rise to higher levels than it did last week, which made international news. So we're not out of the woods yet on that. But so, you know, every place is you know, a bit different. Some places and countries are much more resilient to these sort of effects, and other places aren't. So I'm always surprised when there's a massive disaster in the U.S., like, you know, Katrina or Harvey in New York, in Houston, or Sandy up in New York. I'm always, you know, in the Puerto Rico, Maria. I'm always surprised because, you know, the U.S. is, you know, one of the wealthiest countries in the world, and yet the response to some of these events seems to be almost like a third world response. There's just not enough resources to address the problem.
Oh, I agree with that. I mean, the U.S. Has so many issues. It's all politicians being paid off. If it doesn't make money for them, they don't want to do it, or for their buddies.
Yeah.
But on that note, and we're going to get to some questions from the peeps in just a minute. But I wanted to know really quick, if you were to just be able to put yourself anywhere on the planet to be the safest from any of these effects. I know you probably get asked this a ton, but I know a lot of people want to know. So I plan on staying put right where I'm at. But where would you suggest? What is the safest place? They used to say Canada, but it's heating up higher or faster than
Northern
other
country.
locations. So where is it?
You said the planet, so I can't say the moon.
Oh, is that really safe? You can't grow food there. So
I don't know. I think people like us that are very concerned, we should try to buy a nuclear submarine, and, you know, we can provision it for 2 years, and we can go under the ocean for 2 years, and when
do you
everything.
think the world would be better by then?
Whenever, well, we pick our time when we go down, right? When all hell's breaking loose, we go in our submarine, and we're perfectly fine for 2 years, and then we come up and see what there is left. No,
If there is
anything.
if there's breathable air, you step out of the submarine and die.
It's funny because you know, because yeah, I mean, the nuclear submarine thing is kind of a joke, because Dr. McPherson used to always say, okay, we've got 2 years left to live. And I would say, no, we can just go in, and, you know, people will go extinct. And I said, no, I can demonstrate that people will be alive in 2 years. They just go in a nuclear submarine or in a deep cave. Invalidates the argument that we have extinction in 2 years, right? And so he would always bring that up and say that was my actual solution, which was
so it was a joke, you know, and he took it serious.
Well, I mean, it's a demonstration that people won't all be extinct in 2 years, right?
Yeah.
Like when you throw out time frames like that, I mean, I mean, you know, I knock Guy a bit for his time frames and, you know, changing all of the time. I mean, the ideas are there, but to set a time and say, you know, I mean, people just don't know. Nobody knows, not
right.
him, nobody else. But you know, lots of people, lots of Silicon Valley, you know, 0.1%ers think that New Zealand is the place to go. Right?
That's where my daughter's moving, so I hope that's the place to go.
Well, she can keep a room for you. So they, yeah. So they basically, but don't wait too long to fly down there, right? Because if the flights don't go any longer,
I couldn't take all my horses, so I'm stuck. Okay. I'm here. Yeah, okay. I'll die with them.
Well, you've got horses, so you can always ride up to Canada if you need to.
Yeah.
So New Zealand, you know, and I mean, New Zealand has a lot of things going for it. Islands tend to have more self-sufficiency, right? They have the island mentality is more one of self-sufficiency because you're isolated from lots of the world. But New Zealand has lots of earthquakes, and the ozone layer is also over Antarctica, and depending on how things proceed with climate change, it can start expanding. And if it covered, you know, parts of New Zealand, then the UV would be a huge problem for living down there. Canada has a lot going for it because of the space, right? We have very few people, low population density. We have lots of good soils, lots of, we'll be one of the powerhouses for growing food in the world. We already are, but when grains fail in the U.S. and when fresh water is insufficient and stuff, people will come up to Canada. I mean, the biggest risk to Canada is actually hordes of American climate refugees coming north of the border.
That
right?
Canada should be the one building the wall.
Yes. So of course, we'll welcome these people with open arms. I mean, we can't do anything to stop people coming up, basically. In a crisis. And we'll be kind of indistinguishable from the U.S. Many people in the U.S. will come up into Canada, in the future to because of rapid climate change. So
yeah, I've heard a lot of people say that. So yeah,
we can always go further north too in Canada. But if you go too far north, then the soils aren't very good. You can imagine, soils take long periods of time to develop because you have organic matter. You have plants and things growing and then they die, and then that the remains are organic material, which is fertilizer, and nutrients come from erosion of the rock and things like that. And so soils take a long time to build up. So the soils in Canada are known as very, very young soils because, and also, in parts of the US, because we were covered with ice and that scraped the topsoil off the bedrock. The ice only left 8,000-10,000 years ago. So that's the length of time for the soils to develop. And in the north, there's not a lot of vegetation, a lot of coniferous trees. So the soils are a bit acidic and stuff, but we can, they're good enough to grow some food. So, so Canada will become a powerhouse for food growth. We have lots of fresh water. I can't think of a lot of places that are actually better than Canada. I mean, New Zealand's small. It can only take so many people, right? Australia is in terrible state. Australia is going to be a write-off. So I'd have to vote on Canada.
Good to know. Good to know. Okay, let's get to some. I'm sorry. Go ahead.
Yeah, I just want to say people are very reluctant to leave where they are, though. Right? They're very, very, very reluctant. Even people living on a flood zone. A friend of mine lives right along the Ottawa River, and he was flooded out 2 years ago, and of course it's even worse now. And I can't see him leaving his place. I told him, okay, if you're going to stay there, you need to jack your place up. Jack your place up the floor, right? Use the lower floor, the new lower floor, to store boats and canoes and things, whatever. And
that would be smart.
You just live on the upper floor, so use all the insurance money to do that. And I really tried hard 2 years ago to get him to do this. He would have been seen as a genius if he had done this, but he didn't. So maybe he'll do it this time. I don't know. But I don't really see him leaving. Like, people are so attached to their space, right?
Yeah.
A lot of people be willing just to, they endure flood after year after year and not want to move unless they're forced to move. Or, on the Quebec side, the government's offered money to buy out homeowners that are right along the river. And it'll be interesting to see how many people actually take that offer up. And I don't think it will be that many. I think some people just have to be forced to leave, and then that gets into all other issues, and they just don't want to do it, right? So
right. Yeah, but all the insurance companies are going to go broke, and all that resources needed to rebuild everything after all these disasters.
Yeah.
I just think about that, and that's like another feedback loop, because they're extracting more resources, more pollutants going into everything, and it just is going to get worse and worse and worse and worse.
Right.
So,
but I mean, with Sandy, with Hurricane Sandy coming, topping the breakwaters and the walls off New York and coming in and flooding, a few years ago, thousands of homes were flooded. And those homes, in order for those homes to, when those homes were sold, the buyer would have to jack up the house at 9 feet, or if the owner had not done that. So basically, it did cost homeowners probably about, I think the price I saw was about 30,000, which to jack up the house. I mean, it's you might think it's extremely difficult, but most houses can be jacked up, right? And it's a process. Some people are actually renovating their houses and they want to add a top floor, and it's I think it's cheaper or about the same price to jack up the house and add a new first floor rather than have to, take out destroy the roof and build a floor up and then rebuild. So, it's technologically very possible to do. And people living along the river, they need to do that with the insurance money if they're gonna stay, because also it wrecks their experience along the river. Every time it rains, they're gonna have like post-traumatic stress disorder.
Right. That would mess with my head for sure.
Yeah.
Okay, so man, I could talk to you all day because I still wanted to talk about ocean temps and population geoengineering and stuff like that, but I don't think we'll have time to get into
Well,
that.
we can cover lots of things, lots of different things, or we can cover some things in great depth. It's completely up to you.
Yeah.
Like, if you want to ask me questions, I can keep answers down to just 30 seconds or so on each
I
of these.
want my people to be able to ask you questions because this show isn't just all about me and what I want to know. It's kind of about what they want to know. Interactive interviews, so they get to ask questions too, because not many people can do what I do and get you actually on, and talk to you. So I let them talk to you too. Cool.
Yeah, sure. Of course.
All right. So we got our first question that Oz brought up for us. What about the ozone layer?
Yeah, the ozone
Thanks,
layer.
Osama.
Yes, the ozone layer. Well, the ozone hole was caused by the CFCs, chlorofluorocarbons, and these were developed by DuPont and used as refrigerants. And we didn't know. We knew that they're very stable molecules, and this is why they were perfect to be in the coolant systems. But turns out that they got into the atmosphere, and the chlorines acted as a catalyst to destroy thousands of ozone molecules. Now, we were very, very lucky at that time because rather than using chlorine, bromine was a better, like the same molecule, but with bromine instead of chlorine was had much better thermal properties for refrigerants. The reason why the bromine wasn't used was because it was a bit more expensive. If bromine had been used, then it's instead of destroying 1,000 ozone molecules, it'll destroy 10,000 ozone molecules. So the ozone layer would likely have almost vanished before we knew it was a problem if bromine had been slightly more expensive, cheaper than chlorine, and used for these, on a widespread basis for these coolants. So we kind of dodged a bullet there by using the fluorocarbon, the CFCs rather than BFCs or whatever. So, we recognized the problem. The world came together. There was a Montreal Convention which banned the usage of these, and the ozone layer has been slowly repairing over time. So the big question now is will climate change, will it have a significant effect on reversing the repair of the ozone layer? And that's a bit of an open question now because it depends on, some people argue that if we actually deploy stratospheric, atmospheric aerosols to, up into the stratosphere to cool the planet, which we know will happen because sulfur dioxide is released from volcanic action, strong volcanoes that are strong enough to put the sulfur up into the stratosphere, then that can have an impact on the ozone layers and things. But there's lots of other things that we could put up into the stratosphere that would cause the necessary cooling that wouldn't have no effect on the ozone layer. And it's unclear whether sulfur injections would or not. So the ozone layer, and it's a bit of a separate environmental issue from climate change, But climate change affects so many different things. I don't think we can rule out that climate will have an impact in some way on the ozone layer. But it's not really clear exactly that it will or will not do that at the moment.
All right, great. Thank you for that information. I love to be able to answer these guys' questions. There's a request.
I do want to add one point with
okay.
ozone. A lot of people have the misconception that the ozone layer, ozone is a greenhouse gas, okay, and but the levels of ozone in the stratosphere that protect us from the UV light are extremely small, and you know, so it's not so the ozone level decline or increase is not the reason why we're getting climate change, global warming. I mean, that's CO2, that's methane, it's nitrous oxide, things like that. It's not, the ozone change is not a significant factor. Some people have the misconception that, you know, the ozone layer change is the reason why we have climate change, and that's not correct.
Okay. I didn't know that, but thank you. That's really important to know the difference. Osama was the person who asked that question. He is a huge supporter of yours. And I just want to take a second to remind people that you need supporters. Go to his website and donate, you know, whatever you can, a couple bucks, and help him keep up with his good work. So thanks, Osama.
And keep me in cat food for my co-host.
For Shackleton.
Yeah, yes, you know the name Shackleton.
We actually have a request for Shackleton to be on camera. So
I can try. I don't know where he is. I you know, I was cold this morning and I was still wanted to sleep a bit, so I went wandering around looking for a cat, any cat, and I found the one. I found Mop, who you know, he started hissing at me after about 5 minutes.
Some cats just don't like that.
So, yes. So.
Yeah, but Shackleton's a huge celebrity, so everyone wanted to see Shackleton.
Yeah.
There are more questions. Oz wants to know, recently you referenced superstorms and stated that arsenic and ethane were detected in the atmosphere months later. Please explain that dynamic more. Thank you. Thanks,
yes.
Oz.
So I just posted 2 videos yesterday on Pyro Cumulonimbus clouds. So Pyro clouds so cumulonimbus clouds are the thunder clouds, thunderstorm clouds that we see. Cumulo is the you know, cumulus clouds. Like when you talk about cloud names, it's all of these different hyphens that are put together. So the cumulo is like the puffy cumulus clouds that we see. Nimbus means rain-bearing cloud, and these cumulonimbus clouds. So there's huge convection. So there's a lot of heating at the surface. There's a lot of hot air rises. The hotter the air, it rises much faster. So on the plains, after a day of heating, you get tremendous rises of air that carries water vapor up. The water vapor condenses into clouds, and there's a huge amount of vertical winds going up inside this cloud, and it generally tilts over, so it's tilted a bit, and it goes right up to the top of the lower atmosphere, the troposphere. It goes right up to the stratosphere and you know, the stratosphere troposphere border, and it actually punches through because it's got so much vertical velocity. It punches right through and goes up into the stratosphere a bit, but it generally flattens out into an anvil shape, and that where it flattens out, that flat part of the anvil, that's a border line between the upper atmosphere, the stratosphere, and the troposphere. Now, all of the weather happens in the troposphere, rain and things, and up in the stratosphere, particles can stay up there a long time until gravity pulls them out and pulls them down low enough to come into the lower atmosphere, where then they can be rained out in about a week. So they'll be rained out within about a week in the lower atmosphere. They can stay up for several years in the upper atmosphere. That's why when a volcano goes off, if it's very powerful, it can inject the sulfur, you know, and CO2 and water vapor and ash and all these other things up into the stratosphere. And once it's there, it takes a long, long time to come down. So the sulfur can stay up there for several years and cool the planet for several years when there's one of these volcanoes. So this volcano is no longer just a regional or local thing. If it punches through into the stratosphere, it becomes a global climate changing thing. Pinatubo in 91, 92, it lowered the Earth temperature about half a degree Celsius, so a degree Fahrenheit, for a couple of years. Okay, so what's happening now is that some of these storms, some of these fires, these wildfires, you know, think of how hot they are, and they're creating tremendous amounts of hot air over a large area. They're burning a lot hotter than they used to burn. That hot air rises very, very quickly and carries a lot of water vapor. There's a lot of water inside trees and things that are burning, and that water, liquid water inside those trees, then vaporizes into water vapor and gets uplifted very quickly. So the process is, so it triggers one of these, it triggers basically a thunderstorm. It triggers a huge thunderstorm. And so a good example is in British Columbia in 2017 in August, there were these massive fires, and I showed on Earth Null School, you can look at the some chemicals and different particles in Earth Null School, and you can see the progression of these fires. It triggered 5 of these pyro clouds, and these pyro clouds have very terrifying properties. So there can be a lot of rotation at the ground, so they can generate fire-nados, if you like. They can generate tornadoes or small twisters at the ground. And when there's enough rotation, it can pick up larger materials, because larger burning materials, not just small embers, but larger chunks of wood and stuff. And it can actually, because it's spinning around, it can actually toss these things about 3 miles in any distance from the center of rotation, and these can start other fires. These can start other fires around. So firefighters are all near the original fire. They can become surrounded by fire, essentially.
Oh, yeah. Your last 2 videos were great on that, and it's kind of freaky to see the tornadoes, the fire-nados.
Also, the problem is that there were 5 of these formed in BC in the space of a few days in this fire, and there was one of them. There were also fires in Washington State, and there was one of them formed in Washington State at that same time. Yes, so not only that, but it creates a thunderstorm which has lightning. Now the thing is there's another problem, is that often the ash and stuff, like planes have flown into this thing. They've also flown into thunderstorms, and the planes flying into these pyro clouds is completely black inside the center. Like, no, it's like the middle of the night. There's no light at all. Like they're so thick that the light isn't getting in because there's ash mingled with all of the. It's not just a normal thunderstorm. There's all this ash and smoke and carbon and all kinds of stuff. The other thing is that ash and smoke and carbon can suppress rainfall from these thunderstorms, but there's still the separation of charge. So there's still lightning from these storms. So the Fort McMurray fire in the tar sands was a huge pyro cloud, and lightning was generated from the thunderstorm 22 miles away and started additional fires 22 miles away from the original fire. Okay, this was another problem. So, and we've also had these in Portugal. We've had these in Australia. There was a fire in Australia. You know, they call it Black Sunday or something. Like 170 people killed, 1,700 square miles burned down, and so this is a fairly new phenomena. It is being studied by scientists. The American Geophysical Union Conference, Earth Scientists Conference in December in Washington, December 2018, they had a whole session devoted to studying this. So my second video, I go through, I talk about some of the key papers. One of them is Russian. There's one from Portugal on that fire. There's a couple on the Canadian fires, one on the tar sands fire, things like that. So this is a new sort of consequence of rapid or abrupt climate change.
Yeah, we'll probably see a lot more of those. Let's try to get through some more of these questions because we're
Yeah.
running.
So I'll try to be very, very quick. So in my response. So
okay. I know it's hard because it's so in depth. Or there's a lot to it. As Shiva, some YouTubers are warning of things getting too hot while others saying it is going to get too cold. Which view might be correct, and might one cause the other? Go for it.
Yeah, well, no, it's a good question. I mean, we had a very cold winter in North America, and it all comes back to the fundamental thing is that the Arctic is warming super fast, right? So that cold air in the Arctic doesn't just disappear. A lot of it comes far south in these troughs of the jet stream. We saw that this winter in North America. Right now, parts of Europe went from spring, buds out, birds out, basically spring to, a dump of snow. Parts of the, Minnesota, I think, got 10 inches or something of snow just yesterday or day before, right? So all you need to do is go on Earth Null School, select 250 millibar, which is the height of the jet streams for height, and have a look at those jet streams. And if it snows in your place where you are in May, you can look and the jet stream will be dipping and low right over your place for sure, right? So the jet stream, that it acts as a wall between cold Arctic air and humid, more southerly air. And when it dips down, that cold air has a direct route to get to where your location is. So climate change is messing up the temperature balance on the Earth. It's messing up how heat is transported from the equators northward. It's rapidly warming the north. It's disrupting weather patterns around the world that can cause strange things to happen, like snow in the middle of the Atacama Desert, for example, which is the driest desert on the planet. Sometimes it might not rain there for 10 years, and suddenly they're getting 30 centimeters of snow dump, or a foot of snow dumping there. Why is that happening? It's because the jet streams have are completely disrupted. So weather patterns have changed. And the reason why that's happening is because the Arctic is warming so fast and losing sea ice and snow cover and becoming a much darker place and absorbing a lot more solar radiation. Also, the oceans are key too, right? Because the equators are hot. We know that. The poles are colder. That heat tries to move from hot areas to cold areas. And it does it by the movement of air in the atmosphere and the movement of water in the ocean. And the air transports about two-thirds of the heat that moves from the equator to the Arctic is transported by the air in the air current, and about 1/3 is in the oceans. That's about the ratio. So basically, this is why, one of the reasons, global warming, warming is the general trend. If you look at the overall temperature of the planet, it's warming, but nobody lives in an average place, right? Nobody experiences the average. We're all experiencing, there's local effects that influence what we see. So so, we really need to put to rest the idea from these GSM people,
global solar
solar
minimum
people.
or whatever.
Yeah,
mini ice age coming. Yeah. Okay.
The sunspots. When there's these 11-year cycles. With sunspots, that's a 0.1% effect. Okay, it's 0.1% change. It's the sun output is changing, and it's cyclical. And if there's no sunspots for many cycles, then that 0.1% will be in place for a while. But the effects from us changing the chemistry of the atmosphere and ocean, it dwarfs any of these solar changes.
Okay, great. Good answer. So we had a couple of questions that I missed one earlier on overpopulation, but I'm sure you'll address it. He says, it's my favorite topic. Actually, I think a lot of the people on this channel, it's their favorite topic because nobody talks about it, and we're trying to fill a need here. He says, Paul, are you in favor of government subsidies to reward the child free by choicers?
Yeah, I think, I mean, this is always a touchy subject, right? But we can't
Mm-hmm.
ignore. So for a long time, I've been saying I think we should introduce a maximum limit for of children globally per family, and I tell people, let's start at 10,
10.
right?
Oh my
Yeah,
God.
10. Yeah, yeah. Who's going to argue that? Oh, I want 11 kids. 10 is
I live in Utah. I think
okay.
there's a few people that might argue that.
Okay, but let's say,
I'm just kidding.
I think we'd have the possibility of getting this enacted, all countries agreeing and saying, yeah, 10's okay. And then once we have a number, right, we meet every year and we say, well, can we move that number down? Can we move it to 9 and 8 and 7? And can we move it eventually down to 3 or something, right? Like everything is in place, the mechanisms are in place, the bureaucracy is in place, for a number, and then you just change that number, right? And if you say 10, then it's all the mainstream papers around the world reported. It's on the news. There's Fox News has talking heads talking about it, pros and cons, right?
And then
It
people
becomes,
start saying, well, that's not low enough. That's not going to do
yeah,
anything.
yeah, it becomes an issue. Like it becomes talked about. It's not an elephant in the room anymore, right? So I say it kind of at first I was saying it kind of jokingly, right? 10 won't do anything, right? But sometimes you have to start small, right? And then people start thinking about it and then talking about it and stuff. And then you have everything's in place for you to lower the number, right? You just have to agree. It's okay, we'll lower the number, we'll lower the number, we'll lower the number. I
But
mean,
that
yes,
will take too long to put it to have
well,
any
if
effect,
you review
really.
it every year, yeah, I mean, you can always ramp it up faster and so on, but you have to start somewhere, and people just don't even want to talk about it now. I mean,
Yeah.
the point is it's a huge moral issue because people will argue morally that nobody should be controlling the number of kids that I have, or
I would argue that it's immoral to
not. Yes, well,
not and ruin our planet so the rest of
right,
us can't live.
right. So that's the question. So the question is we're at we just reached 7.6 billion, I believe, recently. I don't
I
know.
thought it
So
was
we get
7.8 billion, but
7.8. Okay. Really? 7.8? I haven't looked for a few
I could
months.
be wrong, but I
I
think
think it's 7.6. I'll have you bet
okay.
on that. Anyway, anyway, yeah, like, so so here's our choices. We either cap that number and start reducing that number, or that number continues to rise exponentially, the rate of at about a 1.4% increase per year. And that's about 270,000 people. Every morning, births minus deaths is about 270,000 people,
Right.
every single day, right? So,
Right.
I mean, so we either stop this madness, we stop this, or the population increases to 8 to 9, to some number, and then collapses, right? And there's tremendous there's all these people all these young people that are being born and have no influence on anything that's happened up to now, have no future, right? So and there's mass starvation, and we end up with 1 billion people or 100 million people, who have to move up to northern Canada and the Arctic because the world is completely trashed and can't support life any longer.
Right. People are going to die one way or another if we don't turn it around.
Right. So, I mean, we can't not talk about this. And, if we start meetings and say, okay, we're 10-child limit, who's gonna not attend such a meeting, right? It's such an absurdly high number that, most people would have no problem with that number.
Right. Plus 50% of the births are unwanted, unintended. If we could just improve getting birth control out to people, or even offering free vasectomies, or things like that, we could go a long ways. And then also come up with some more ways to maybe reward people who don't have children, because right now they're rewarding people who do by higher tax breaks for them. If they have more kids, they get more money back in taxes. If we reverse that and take away those breaks and instead throw a little extra tax breaks to those who aren't having kids because they're not putting the burden on the system and everything else, it only makes sense. So,
Yeah.
I mean, not that I think this will work in any way, shape, or form because it's too damn late, but it's just, we have to try something. We have to try, right?
Yes, and it's not just it's the population and then the consumerism with, what all of the stuff that we've been convinced that we need, which most of it is, if you look around your house, what do you really need? Right? I mean, most of it can
Yeah.
vanish, right? You don't
We have mostly junk that we don't
yeah,
really need. It's just there to look at.
yeah,
Sandy, Environmental Coffee House, you did an interview with her, a great one, by the way.
thanks.
It's related. So just please try to ask my question about how to depopulate without people saying it is a conspiracy theory by the deep state. I don't think there's some people you could ever convince otherwise. What do
Yeah.
you think?
Yeah, no, I think we're either going to do it in a controlled, organized fashion to stop this crazy exponential population growth, or the planet is going to do it for us in a chaotic fashion. Now, it's not likely. I don't think it's likely that billions of people are going to die from, like, when there's global food shortages. I don't think that the cause of death of huge numbers of people is just going to be so much starvation as bullets, probably.
Oh yeah. Oh yeah. People's fighting
Right.
for food.
The problem is that when resources are in very restricted and in short supply, then it just causes conflict.
Yeah.
Within countries, among countries, and it's like a free for all. And a country like one of the things that we're seeing is a big uptick in right wing right wing governments, and even fascism, right? And the problem is that as countries get more and more affected and hammered by climate change, they turn inward. They want to shut their borders. They want to build walls. They don't want immigration anymore, right? And these sort of things, we're seeing this pattern developing around the world, and it's very clearly related to abrupt climate change.
Yeah.
So
There's already climate refugees and
yeah,
people
so
don't understand.
what's really, really strange is these governments, they're denying that climate change exists, and yet all of these policies is their response to, to abrupt climate change, right? So that makes it even more ironic than, it's just craziness.
It is. It's absolutely insane. Okay, we probably have time for like one more question. Oz, pick the best question, would you, for me?
I
I
don't
mean,
see
we're actually
one.
over time.
Yeah, I
So,
don't see one. Sorry.
oh, you don't? Okay, well, then, dang. I guess cool. I mean, it's already been over an hour, Paul. I know your time is super
Yeah, no,
valuable.
fine. That's good. It's Friday morning. What else am I going to be doing Friday
I
morning?
don't know. I enjoy the heck out of talking to you. Okay, so since that's okay, I'll just go into it. Geoengineering, that's pretty much, it would be a Hail Mary. I don't want to do it. I don't want to go there. Um, so I was just wondering what you were thinking. I've heard you talk about it before. Uh, and actually, they do bring this up occasionally on the news. They'll say, "Oh yeah, scientists are working on a big satellite to block the sun and stuff like that," but they never tell you why. I mean, if scientists are concerned about it, but they don't, the news doesn't tell you why they're so concerned about it. They just tell you what scientists are doing with no explanation whatsoever.
Right.
And when they do talk about climate change or the biodiversity study or the paper from the UN, and it was like a 15-minute news cycle in the morning, and then you didn't hear about it the rest of the day. It was insane, the lack of coverage on it. And it was like probably the biggest story on the face of the planet as long as humans have been on this planet. And they give it 15 minutes. It's like,
no, I know. And I mean, I'll do some detailed videos on the what's come out of that report.
I'm looking forward to that very much.
I was trying to find out when the 1,500-page report would come out, because it's just the 40 pages. But maybe I'll do something on what's come out so far, and then. But I mean, for a long time I've been saying, we have to declare a global climate emergency. And more people are recognizing that that's the case. And it's just a matter of time before, you know, much of the many nations of the world are actually have that type of thinking. I mean, it's cities, it's a few countries have just, you know, like I mentioned, just recently had this declaration. You know, and then okay, so then what do we do about it? I mean, the, you know, climate adaptation and mitigation are terms that the Intergovernmental Panel on Climate Change talks about for a long time. They come up with these scenarios, low emission scenarios, like RCP 2.6, representative concentration pathway 2.6, you know, low emission scenarios that, and those scenarios require carbon dioxide removal. They assume that carbon dioxide removal will be deployed, even though they don't explicitly talk about it.
Right.
There's many startups that are looking at ways to take CO2 out of the atmosphere. There's there's some very interesting companies that are looking at ways to have mass planting with high success rates of trees. Like we're talking about 1 trillion trees around the planet, or 2 trillion trees, you know, sucking up huge amounts of CO2. We tend to think only of solutions, things like that, for on the surface of the earth, but the oceans, I think, are a key. I think, you know, we could stimulate phytoplankton blooms in areas of the ocean that are completely unproductive for as far as life is concerned, because they're lacking nutrients, and we could stimulate marine growth. I mean, if the oceans, if we could bring back teeming life in the oceans, which there was 100 years ago, that would suck enormous amounts of carbon out of the atmosphere and provide lots of food for people. But, you know, there's no good in just extending things that we're doing. So I would be against, say, doing all of these solutions and still having exponential population growth. It just doesn't make sense. Because we'll run into a wall further down the line. And the other
energy
thing
use per capita needs to go down as well.
Yes, that's right. And the other thing is solar radiation management. We have this technique that is fairly inexpensive that we can cool the planet with. And we're talking about, we're not trying to, you know, a lot of people say, well, we've messed things up enough, you know, trying anything else is, you know, let's just let ourselves go, you know, collapse. And then, you know, maybe there'll be some life left to, you know, maybe we don't take out all life with us. But, you know, I talk more about trying to, let's just try to restore a stable climate, restore a healthy climate that we had, you know, even 50 years ago, 100 years ago. Right? So we're talking about getting CO2 levels down to, you know, 350, 300 parts per million. We're talking about, you know, having a cold Arctic again, having you know, ice and snow up in the Arctic. So I'm, you know, the solar radiation management things, I mean, the very volcanoes happen frequently, and they cool the planet if it's a big enough volcano. And we know it's what the chemicals are that do that, the sulfur. And, you know, we produce tremendous amounts of sulfur in the lower atmosphere from coal burning. Coal has a lot of sulfur content, especially if it's low grade coal, and we burn it in power plants to produce electricity. We have these big smokestacks, you know, the smoke and ash comes out, and also the sulfur comes out, and it's in the lower atmosphere, and it's harmful to people, right? All we need to do is take the sulfur that comes out of one power plant, right? That's the amount of sulfur that we would need in the stratosphere to cause significant cooling of the planet.
Would that block sun, or, you know, the light needed for plants to grow efficiently? I mean, wouldn't that be a problem?
No, it's just we're talking about a small fraction of the light coming in, a tiny fraction of the light. And you could argue, well, I watched the first hour of Snowpiercer last night, and this movie, you know, they tried injecting stuff up into the atmosphere, and they froze the whole planet, which killed all life on the planet, except for people in this train circling around the planet. So I just watched the first hour of this movie on Netflix, and you know, I mean, it's not all or nothing, right? I mean, we put a little bit of sulfur up there and we see the effect, we confirm the effect, and we put a little bit more, and then we keep the snow and ice in the Arctic, and that gives us time to suck huge amounts of CO2 out to restore. We want to restore a healthy climate. That's all. We're not trying to, you know, we're trying to survive. We want to. So So I highly recommend people just Google Healthy Climate Alliance and have a look at some of the things that they're doing and some of the ideas. And, you know, if people turn their thinking around, turn their thinking to basically all we want to do is try to get back the planet that we had, you know, say 50 years ago.
Right. Okay. I'm sorry to try and cut this short. I think I'm getting the signal that I need to wrap it up because of Oz's time. But
yes,
one really fast question. What do you think of the activist realm? And there's a new thing coming up. It's called Debt Strike, where they want to stop paying, you know, get a bunch of people to stop paying their debts until they do something about the climate, the big corporations and banks.
Yeah.
And then, of course, there's Extinction Rebellion. Just really quick, what do you think about those two things? And would you support or cheer on? I know you cheer on Extinction Rebellion, but what about the direct action like Debt Strike?
Yeah. Well, all of those things are, you know, it's a bit of short-term pain, but for just trying to preserve the life on the planet, right? So, yeah. So I think you know whatever it takes. I mean, nothing's worked so far, really, right? So
right.
Different
but
things.
Yeah, at this point, we have to be desperate and do whatever the hell it takes.
Yeah. Exactly.
Yeah, that's my thinking. I'm there. So yeah. Awesome. Thank you so very much, Paul. I kept you for so long. It's already...
Oh no, don't worry. It's pouring. I'm having torrential rains here again. You know, the Ottawa River. I may go and do one of these videos. I don't know if you saw the video when I was in front of the raging water.
Oh, I love that. Yes, I did.
So we're getting really heavy rains. If they continue, I might go out and do you know, walk down the creek, the river, and
awesome.
You know, video like that. I'm not.
Those are my favorite videos that you do. But and I love your rants when you just get mad and rant about something.
Yes.
Like yes.
Yes. Exactly. Yes.
That makes me very happy. Okay, well,
good.
I'm gonna say goodbye to my peeps. I didn't even list any of them off, so I'm probably gonna miss somebody because there's, you know, people not. But Sandy, of course, is here. Trev B5, S Shiva, thank you. Osama, of course, always thank you. Anita, thank you for being here. Chris Foster, you made it. Thank you. Ace Sotana, thank you for coming. Book Hermit, always great to see my favorite critic. And did I miss anybody, Oz?
Human.
Oh, Human. Thank you, Human. Love you much. He's my moderator. He's awesome. Oh gosh, where'd I go? All right, guys. I think that's all. Thank you, Paul, very much. Have a very, very good day. If you want to hang out and talk to you for a second after, we're gonna close this down so Oz can get on with his very, very busy life. I'm not the only person he does this for, so I can't be too selfish. So thanks, guys, very much. Remember, tomorrow, 11 a.m. Mountain Time, I will have Jennifer Hines on with me, with Graham L. would be my co-host, and Jan Wiley to talk about the climate searchable database that they are working on, and also some series of videos that kind of attach to that with the conclusions that are come up from the database. Anyway, thank you very much and have a very good day, you guys. Bye-bye.
Okay, goodbye. Thank you. Yeah, I do have to run because my kids are home from school. Okay.
Okay.
So, thanks a lot. Okay.
Thank you, Paul.
You're welcome.